All right, example 2. The radius of a circle is decreasing at a rate of 4 centimeters per second. Let's find the rate of change in the area of the circle whenever r is equal to 3, so our radius is 3 centimeters, and whenever the radius is 7 centimeters. So step 1, what we want to do, we want to draw a picture of this. Now in this case, our picture is going to be a nice basic picture. So it's just a circle. There's our radius. So remember, the radius just goes from the center to the edge. All right, so step 2 now. Let's figure out what we know. So what do we know? So if we go through here, so radius of the circle is decreasing at a rate of 4 centimeters per second. So because the radius is decreasing at a rate of 4 centimeters per second, so the rate should tell you that's one of our derivatives, or one of our rates. So in this case, since the radius is decreasing at a rate, that tells us that we know dr dt equals, and in this case, decreasing tells us that the rate is negative, so negative 4 centimeters per second. All right, step 3, what do we want to find out? So now we want to know the rate of change in the area, so we want dA dt. And when do we want it? So be careful. I didn't put the r equals 3 centimeters, r equals 7 centimeters in with what we know, because that is specific to what we're trying to find. So that's part of what we want. So in this case, we want dA dt whenever r equals 7, or sorry, r equals 3, and when r equals 7. So we should have two different answers for dA dt when we're done. All right, step 4, we want to come up with an equation to relate, in this case, radius, what we know, and area, what we want. So the rates of change changing with respect to. So some equation to relate area of a circle and radius of a circle. So, yeah, that's right. It's probably area equals pi r squared, right? So that's the only equation we have for area of a circle. And conveniently enough, it does have radius in it, right? All right, so step 5 now. So we have our equation. Now we need to implicitly differentiate both sides of this equation with respect to time. So the derivative of a with respect to time, of area with respect to time, is dA dt. The derivative of pi r squared, and remember, pi is not a variable, it's a constant, right? So this is a constant times radius, which is a function in terms of time, squared. So this is going to be 2 pi times r to the first power, right? So remember, using the power rule here as a part of this chain rule for implicit differentiation. So 2 pi r to the first power times the derivative of r with respect to time, so times dr dt. All right, and so then the last step, plug in everything that we know and find out what we want. So find our answer, basically. So here, so we're going to do this in two different pieces because we have two different things we want to know. So let's start when r equals 3. So we want dA dt. So when r equals 3, then we have 2 times pi times 3. And in this case, a good practice is to write your units in here as you're solving this. So 2 times pi times 3 centimeters times dr dt we knew was negative 4 centimeters per second. So the reason I recommend writing your units in here is because what's going to happen is it's going to make it very clear what your units are going to be in your final answer. So in this case, now you can get an idea of what those units are going to be by just looking at what you have a rate of, right? So in this case, we should be ending up with a rate of change of area with respect to time. So we should have some units of area as our numerator of the units, and some units of time for our denominator. And in this case, because we know we're measuring units of length in centimeters, so we should end up with centimeters squared per second. And so if we work through this, notice, so 2 times pi times 3. So we've got 6 pi. 6 pi times negative 4 gives us negative 24 pi. But notice what happens here. So centimeters times centimeters gives us centimeters squared per second. All right, so now that we found our rate of change for the area with respect to time whenever the radius was 3, we need to do this again for when the radius is 7. So when the radius is 7, it's the exact same process. So we just sub in what we know. So remember, dA dt was 2 pi r dr dt. So now, dA dt is going to equal to 2 times pi times our radius is 7 centimeters now, times our dr dt is still negative 4 centimeters per second. And so cleaning this up, multiplying everything out, so 7 times negative 4 times 2 pi, we end up with dA dt equal to negative 56 pi centimeters squared per second. And we're finished.